topics presented in this video include quantum computing, QuBit arrays, entanglement, superposition, quantum QuBit operations, how to measure quantum qubits, how to enable quantum qubit gates, future of quantum computing, machines fused with classical computers, quantum computing resonators, and a proposed quantum computing hybrid platform architecture with other digital platforms. So the behavior of quantum mechanics as it relates to subatomic particles explains the complex behavior of atoms. For instance, electrons can exist in multiple distinct states at the same time. This is known as superposition, and it's impossible to know for sure at any given instant what state an electron may be in, because the very act of observing the state, it changes. So subatomic particles can be entangled so that change to one influences another. So my idea is to develop algorithms for optimization problems in data storage and energy efficient data retrieval with applications in autonomous vehicle systems and autonomous robots with some influences on artificial intelligence. Therefore, in quantum computing, quantum logic gates are represented by unitary matrices. The most common quantum gate operates on spaces of 1 or 2 qubits. So, as matrices, quantum gates can be described by 2 to the n times 2 to the n sized unitary matrices, where n is the number of qubits that the gate acts on. The variables that the gates act upon, the quantum states, are vectors in 2 to the n complex dimensions, where n is once again is the number of qubits of the variable. So the base vectors are the possible outcomes if measured, and a quantum state is a linear combination of these different outcomes. Therefore, my work in quantum computing related applications, I will be exploring those applications in communications, distributed navigation, and system diagnostics. That includes cryptography, software debugging, and machine learning capabilities. Okay, let's bring quantum power computing into proper perspective. For instance, a 3 qubit computer runs 8 options in parallel. Therefore, a 5 or 6 qubit quantum computer, this system will run 32 or 64 options in parallel. We can continue to increment. 30 qubit quantum computer runs as many options as the ones stored in 134 megabytes. And scaling the qubit quantum computer to 50 qubits, we're talking about 300 terabytes of information. So we're reaching the quantum supremacy, and it is totally amazing with a phenomenal computation capability. So it is important to note that the next generation of computing system will encapsulate the quantum computing technologies with that of classical computers, thus creating a phenomenal symbiosis of computers of the quantum magnitude collaborating seamlessly in a hybrid platform to become a very powerful computing machine. So, quantum computing architectures and technologies. The quantum gates are performed and enabled by sending electromagnetic pulses at microwave frequencies to the qubits. Electromagnetic pulses have a duration, frequency, and phase which determines the angle of rotation of the qubit state. For instance, for a single qubit operations, only one pulse type needs to be calibrated. However, in a 2-qubit gate, tuning is required to calibrate the interaction between the two qubits by driving the control qubit with a microwave pulse tuned at the frequency of the target of the second qubit. Once the qubit operations are completed, you can measure the qubits by sending a microwave tone to their resonators. In superposition mode, a qubit can be more than one thing at a time through quantum mechanics, which is a principle called superposition. Thus, given quantum computers, their speed and parallelism enable them to work on millions of computations at a time. So when qubits are linked with other qubits, they are in a entanglement mode. That is a state of one qubit can depend upon the state of another qubit. When entanglement combined with superposition, the quantum computers have the phenomenal potential to simultaneously process a vast number of computations. Therefore, the numbers that describe the amplitudes for different possibilities define kinematics, the space of different states. The dynamics describes how these numbers change with time for a particle that can be in any one of infinitely many discrete positions, a particle on a lattice. The superposition principle tells you how to make the state. Quantum qubit architectures and hybrid autonomous platforms. Here is an illustration of a fusion of quantum qubit architectures with a hybrid data flow technology, yielding a sophisticated, intelligent autonomous platforms used in intelligent drones and intelligent autonomous robotics. The main objective is to concatenate quantum computing as a paradigm by fusing artificial intelligence in deep cognitive machine learning. In addition, my goal is to integrate cloud computing and multi-agent system software models in order to create mathematical algorithms and software models with applications in smart drones and intelligent robotic systems and platforms.